All right, what is going on, everybody? My name's Tim, and we're going to be solving a Leetcode question called Can Jump from the Top Interview 150. And of course, we're doing this in C#, which I'm excited for. And this is an interesting problem. First time I tried solving it, I actually did solve it. And maybe we can look at that solution later, but after solving this problem, I looked at the other solutions and discovered that I was not using technically the right algorithm. I think my solution was pretty much the correct answer, but I don't think I did it in a way that maybe was a little more complicated than it needed to be. So I'm going to be kind of going over the easiest way to do this in C#. And I think this problem is not that hard to understand, but I think what's hard about this problem is if you did it without knowing how to do it. Like, if you've never solved a problem like this, I think this is a really tough challenge. Because if you watched my other video, I think it was like remove elements in an array or something. Most of these array problems are pretty much all use pointers. Like, that's how you solve it. But how you use pointers in this context is a little different. So this is called the greedy algorithm. And, well, let me read the question. So this question is called Jump Game. You're given an integer array, nums, which we're assuming here that this array is positive. Does it say that anywhere? Can it be negative numbers? I don't think it can, but does it say that anywhere? Oh, okay, in the constraints down here, it can't be less than 0. Okay. Cool. I was reading this like it said I, not nums I. So meaning any element in the array cannot be negative, cannot be less than 0. So you're given an integer array nums. You are initially positioned at the array's first index, which you do not need to. If you were to solve this problem, you don't actually have to start on the first index. We are going to for this solution, but I think the one I coded, I started at the back. Could be wrong though. And each element in the array represents your maximum jump length at that position. So if you're at nums 0 in this array, your maximum jump length is 2. So 1, 2. So you can reach this one. Okay. So return true if you can reach the last index, or false otherwise. So when I first solved this problem, I thought it was saying return true if you can go past the last index. But it's sufficient to just land on the last element. So if this last element were 0, you would be fine. It would still be, like, if you can't go any further right here, if it's 0, it's still true. It would return true. So this is a Boolean method. We're just returning a Boolean. So return true. So return true or false. Okay. So public bool can jump. The input is an int array called nums. So we're going to create a pointer that represents the max reach we can get at any index. Meaning, if we're here, we can go 2. If we're here, we can go 3. So you might be tempted to go like int max reach equals nums I. First of all, we're going to be updating max reach as we go, so this is bad to start it to the first element. The other reason why this is bad is the maximum you can reach, and this is the hard part to understand, is not actually nums I. Why? To me, that is the weirdest part about this algorithm. And if I were trying to solve this on my own and I was trying to do this solution, first of all, it'd probably take me an hour to even come up with this. And then if I did come up with it, which honestly, depending on how good I'm programming that day, I might even not come up with it. Even if I were to come up with this kind of solution, I don't think I would have come up with a very critical observation of this problem is that the max reach is not the value of the element. Because you're literally told, right, that each element in the array represents your maximum jump length at that position. And that is the critical part, at that position. So what do I mean? So if we're at index 0, okay, the max reach we can go is 2. If we're at index 1, the max reach is 3. 1, 2, 3. Right? But it's not true. We have to account for the last position that we were at. So really, the max reach at this index is I, so where you're at in that index, plus nums I. So really, max reach is equal to nums I plus I. Okay. But we're going to update it as we go through, so we're actually going to start it at 0. And this will make more sense. But hopefully my explanation there makes sense. So we're going to iterate through the array. So int I, set it equal to 0. And then we're going to iterate through the array. So I is less than nums.length. And then we're going to do I. Oh, didn't mean to do caps there. I++. Beautiful. So first thing we're going to check is if I is greater than max reach. Why are we doing this? Well, it's saying the index that you're at is unreachable. So for example, if this first index was 0, so 0 is less than max reach, we're good. Or wait, I shouldn't have done that. Let's do the second one. So let's say it was like 2, 0. Well, let me keep coding this. I think the point I'm trying to make doesn't really make sense till you see the rest of the code. But for now, all you really need to know is that what this is saying, and we'll see why this makes sense. What this is saying is the element we're at, I, or the index we're at rather. So if this is 2, we are at 1 in this array, right? So for this index, it is greater than the max we can reach. So we cannot reach this index. Now in this case we can, but like let's say we go here. If you got to this point in your max reach, so this would be, I would be equal to 1, 2, 3, 4, so 3, right? Because it's 0 index, so 0, 1, 2, 3, 4. So this would be 3 in this case. And, well, now we need to figure out what max reach would be. So I kind of said this already, but max reach is equal to nums I plus I. So we take the max of max reach and nums I plus I. So whichever one is greater, we want that to be max reach. So we will assign that value to our variable max reach. Okay, so now let's try to step through this code and see what it's saying. So it starts at 0 for this first, or let's do this one. For this one, the index is 0, max reach is 0, so it wouldn't be false. Then max reach would be set to either 0 or nums I plus I. In this case, it would be 3, because the index is 0, I, and nums I would be 3. So max reach would now equal 3. On this next one, max reach would be equal to the max of nums I plus I, or max reach. So in this case, it would be the index would be 1. So 1 plus 2 would be 3. And max reach is already 3, so max reach would remain 3. When we get to 1, max reach would still equal 3. And it would be I, which is 2, plus num's I, which is 1. So it would be, this would still equal 3 at the index of 2, right? I would be 2 and num's I would be 1. So 3 and max reach would still equal 3. And then we get to this index, which would be I would be equal to 3 and num's I would be 0. And max reach would still equal 3 at this point. So I, in this case, it would still, wait. Yeah, so max reach would still be 3. We get to this index, max reach is equal to 3 still. But I, in this case, is 4, or yeah, 4, plus the value of this index is 4, so 8. So 8, and the max reach would still be 3. If I was 4 in this situation, 4 is greater than 3. So this line of code would never even get reached. It would already return false. Because at this point, max reach, I'm sorry, this explanation is confusing. When we got to this point, this line of code has not been ran. So I'll comment it out. When we get to this point, this code has not been compiled. It's within this if statement. So max reach would be equal to 3 at this point. And 3 is less than I, which is 4. So meaning we cannot reach this index. So now the rest of this code should make a lot of sense. So now we're really just going to return true if max reach is greater than or equal to the length of the array. So return true. And that's the only time we're going to return true. So we probably don't need to write this, but just in case, return false. And let's run it. Oh, forgot to put a semicolon there. It's hard because if you're in like Visual Studio, you would get a compilation error. But there you go. Runs fine, so we'll submit. Wrong answer. What did I do wrong here? So if nums is equal to just 0, the output is false, but the answer is true. If, I guess we can just do a check here. I don't know if this will actually solve our problem here, but if the length of the array is equal to 1, return true. Okay, so this outputted false. What did I do wrong? Oh, I see what I did wrong. I did if max reach is greater than or equal to max to nums.length, but it's a 0-based index, so we need to do -1. In that case, if it were 0, we can also get rid of this. That should be good. Because we just want to reach the last element. We don't want to go beyond the length. So there we go. Beats 82% of users with runtime and 78% in memory. Let's see if we can. Sometimes you can submit it multiple times to get better results. Okay, that time. That time it was slower, but yeah, there you go. That's the can jump, the jump game problem. I think I'm going to do another one of Jump Game 2. But yeah, if you enjoyed this video, leave a like, comment, you know, classic YouTube stuff. And I'll probably keep making these. So, hope you enjoy, and thanks for watching. Hope you have a great day. Thank you. Bye-bye.